Hello everybody. Welcome to discussion about recursion. So first of all, we're going to take a look at several different things here. One is terminology here, the different terms we use. We're going to look at a couple different cases here. One of just write stars. That's a simple program that actually prints out a series of stars. One is using the iterative method. The second one's recursive. Number three, we'll look at a linked list and actually counting the number of people in the linked list. It's actually number of nodes. We're going to reverse the lines in a text file, and then we're going to take a look at this program called star string. Okay, so let's take a look at the terminology here. Recursion. So let's go ahead and turn on our pen once again here, and so we see here that so first of all, we have iterative, and that's using a loop. And second is recursion, and recursion is actually calling, I'm just going to read the definition on this one, a programming technique in which you describe actions to be repeated using a method that calls itself. Okay, here we have base case, and this is a case within the recursive solution that is so simple that it can be solved directly without a recursive call. The recursive case, okay, and this here is the case within a recursive solution that involves reducing the overall problem. So notice here, reducing the overall problem here. Okay, that's the key to recursion here, to a simpler problem of the same kind that can be solved by the recursive call here. All right, and then of course our call stack. You're going to notice here that as we're calling the same function over and over, this is the internal structure that keeps track of the sequence of methods that have been called. Okay, so let's first of all we're going to take a look at our first program here, and the first one is actually writing stars iteratively. Okay, so we're just going to write 4 stars on the screen here, and I'm just going to run this in the debugger now. Okay, so we have our function is called write stars. Let's turn on our control structure diagram here just so you can see write stars here. Let's expand the function. Parameter is integer n, and then we have this loop here, and notice here we're going to actually call it with an argument of 4, and it's going to use this loop here to print out 4 different stars. Okay, so you notice that it's looping through, and you can see right down here, let's go ahead and turn on our pen again so you can see the stars actually coming out right there. Okay, so let's go ahead, step through that now. So we'll see here we got 1 star, 2 stars, 3 stars, 4 stars. Very simple here. It's what we've been used to in calling our methods here, and we'll print out a new line. So just pay attention to this new line that we have here. Okay, and then we're done. The program's finished. All right, so let's go ahead now and let's end this program. Well, it's actually done here. It's terminated. Okay, let's go back here. We're going to write a recursive version of the same program. It's called write stars recursive. Okay, and so let's take a look here. Let's put our write stars iterative to the right here. You can see once again we have let's turn on a control structure diagram here. So here, turn on the control structure diagram, and you notice here that the function has the same parameter list, return type is void, the function name it looks the same. Okay, now this is how recursion works. Okay, so it may look the same on the outside here, but what happens, first of all, we're going to write our base case, and our base case is, remember when we said that last item that we did there, that print line, that is what we're going to actually check for first. We're going to say if n equals 0 here. Okay, then we're going to do say system.out.println, and then we're just going to return a new line there. So it's like thinking sort of backwards here. Okay, now what happens, we're going to say here, oh, we are actually we didn't have that base case there. Okay, so that was a base case. Let's put a little comment here right next to it, base case. Okay, and now we have what's called our recursive case here. Okay, so recursive case. All right, and now what we say here is system.out.print, and we're going to print a star. So there goes a star. Okay, and then now here comes a recursive call. So back to our definitions here, we're actually going to call the same function here. So it's write stars. Okay, and watch this here. This is the smaller part of the problem here, n minus 1. So you can see here that each time we call with 1 less than before, and then so now it happens here. We put that in there, and let's go ahead and compile it. It compiles, and let's turn on our control structure diagram so you can see here. Here's our if then else here. Notice there's no loop on that one there, so our else case here. And let's go ahead and run this through the debugger. Okay, so we hit stop on that. Okay, there's the debugger. And now we're going to use this step into, and notice right here, I'm going to actually draw on the screen once again here. Let's take a look here at the call stack. Okay, so right now, if you notice right here, we're actually at Recursive Java here. We're at line number 14. It's a little bit obscure there off the edge there, but let's expand that a little bit so you can see that there. You can see the line number 14, and we do a step into on the function here. Okay, now we can see that n here, so when we draw here, take a look at n is equal to 4, which is not equal to 0 here. Okay, so this is our base case there. So it's going to go into this portion right here. This is the portion that it's going to go into. The first thing it's going to do is print a star, and then here's our recursive part right here, the n minus 1. Okay, so let's go ahead and step through that there. So let's see, we should get our star that comes out there, and sure enough, we get our star. If you look at that there, a star outputted right there. Okay, and now we do the step into, so notice it's on line 9. And at the same time here, if you look to the left here, we see our call stack here. It's on write stars recursive, and we're going to get yet another call into the same function. And you can see the call stack actually increased by 1 there. Alright, and this is going to happen until n equals 0 and it hits the termination case. So we're going to step down there, and now you're going to see another star print out. We're going to step into it again. We're going to step, and then watch another star, step in again, and you can see this call stack's all growing each time here. And now what happens is we print out that star. We got 4 stars. Okay, so now we're going to call again. This is our last call here. Look at this here. It's write stars here, recursive here, and you can see on the call stack here it shows that each time it actually was at line 9 here when it made that recursive call there, but now it's at line number 5 and n equals 0. So what happens in this case here? Oh, look at that. It's actually going to just print out a new line there, and wow, look at, we're done actually. And now you're going to watch this whole entire call stack. So look at this portion here. Pay attention to this right here. And now I'm going to hit the next line, and we're going to see what happens at call stack. Okay, so notice it's on line number 11 here, and it disappears there. We're 8 now. We're back on line number 16. That's the end of our program. So now you can see we just did a recursive version of the same program that we did iteratively. So the next one we're going to take a look at, let's look at our agenda here and see which one is actually the next one. All right, we did write stars, and this one is how many people. Okay, this is the linked list problem here. Okay, so we talked about linked lists last time. So let's go ahead and look at our browse here, and we're going to see, let's see, how many people. Here it is right here. So here's the how many people here, and we have the list node here, and let's move the list node over here. So this is a generic list node, and we're going to actually, let's just fire this up here, and so you can actually see the structure. I'm not going to type in all this program here, but this is just to give you a visual here. Okay, oh, let's go back over here. Let's fire the debugger here. Okay, so we have a list node. Notice we have a string here. Okay, and each piece of list node actually contains a piece of data and a link to the next node. So what happens, I'm going to create 3 disparate list nodes, actually 4. Okay, so we have Mary, Larry, Joe, and Harry. Okay, and now what happens, we have this other list node here. It's actually start of the line. Okay, and so now what happens, you're going to watch this here. It's a reference here. Okay, and it actually contains Joe. Okay, and so now let's go ahead and launch our viewing canvas here. Okay, we fire up the viewing canvas, and now we're going to take and put the start of the line right over here. Okay, and now you can see is that start of the line, actually, if we draw right here, the way the drawing canvas is, it actually is linked to Joe. Okay, and Joe's actually linked to nobody right now, but as we click through this here, Joe's going to link to Mary. Okay, so let's go ahead and do that there. You can see Mary gets linked in next on the line there. Now we're going to see Larry get linked in on the line there, and now Harry gets linked in. And now, of course, when you look at this here, you can see that, oh, Harry here is now linked to nobody here. That's our special case there. That's going to be our base case. That's the null there. Okay, so let's go ahead and take a look. And now we're going to go into the interactions here. We're going to just actually, what I call, hack the program a little bit, because we had these 4 different separate people here that we created. Okay, so these different references here, but really started the line links to all this here. So we could just get rid of all these references here, because they're actually linked by the line there. And then that'll cut these references there. So as long as we maintain from the start of the line there, then we're good to go. So this is to illustrate here on the linked list how it's chained together here. So Mary equals null. Okay, so that cuts that link there. Larry equals null. Okay, and then Joe equals null. And this is like we're actually messing around with the state of a running program here. We just have it paused. Okay, so Harry equals null. And there we go. We have our linked list. Joe, Mary, Larry, Harry. And now what we're going to do is we're going to actually advance the line here. So, and let's see here. Oh, okay, let's see. Oh, exception here. And the main thread here, how many count start of line? Oh, and let's take a look here and see we have an exception. Let's see here. Let's save this here, and let's launch the debugger again. It looks like I did something here. We're going to go back again and create this line here. Okay. All right. Oh, all right. That's what happened right there. We actually just walked off the edge of it there, and so we just do Harry equals null, Joe equals null, Larry equals null. Okay, Mary equals null. We got our line. Okay, and now we're going to step into, so notice we're on line number 31 right now. We're going to take a look at the function that does the count of the how many. Okay, and now what you see right here is we have our base case. Now this base case here, let's take a look at, this is our function how many. Let's turn on our control structure diagram here. And it's a very simple function, but the first thing we need to do, it's like thinking backwards. We're actually thinking, we're just looking at this last piece right here. When we reach this here, this is the null, which that little dot there means on the control, or on the JGrasp canvas here. Okay, that matches this case right here. Okay, but you can see right now node is actually pointing to Joe. Okay, so we're going to say here it's like, oh, 1 plus, and then whatever count we get on the rest of the list. Okay, so now we're going to recursively call right here. This is our recursive call right here, and it's a little bit behind that there. I'm going to actually move that viewing canvas over a little bit, or down, so you can see that there. We're actually going to say, okay, and now you're going to notice this next node, it's going to actually move right here, and at the same time we're going to watch the call stack grow by 1 element there. Okay, and so let's go ahead and hit the next line on this here. Okay, so we're going to say next. Okay, and once again we're at the recursive call here. It's going to actually go into step into it there, and move to Mary there. Okay, we're not at our base case there, so notice the green arrow right here is line number 4. We're going to hit the down arrow then, and once again we're going to step in again. It's going recursively, and each time it's pushing this call stack down. Okay, and now we're going to go again, and it's going to hit line number 7 there. Okay, now here's the key thing here. Okay, now in this case here, we see that list node. Okay, list node is actually pointing to the object here, which is this one here. It's this reference here to Harry. Okay, and we're going to hit down once again, and we're going to step in. Now what happens, you can see here, let's just note this here, that now the node is null. So we're actually right here, if you look at it, we've reached our base case there, okay? And you can see right there it's going to return a 0 here, and now what happens, you're going to watch our call stack shrink. Okay, so let's watch this, see how this progresses here. It's called unrolling the stack. Okay, so we're going to go ahead and hit the down arrow here. It's going to return 0, okay? And now what happens, you can see here is like count rest. Okay, now watch here, the count rest, it's going to increase here on each return as it unrolls that stack there. You're going to see that increase. Okay, so let's hit the down arrow here. Now you can see that, oh, count is 1. So that counted that first item there, Harry, or actually it was the last item. Now it gets its count as 2, count as 3, and then it returns here, and now what happens, you can see that actually the int count, because now we return back into our main function there, and it's going to be 4. Okay, and there we go, we actually counted there. And so you can see a linked list is conducive to recursion here. Okay, now you can do this as an iteration as well. Alright, so that's our linked list example there. Let's go ahead and close that example. Let's take a look at our next, oh, we can just hit end on the program here. There you go, you can see there the result was there, therefore in line. Alright, next example is coming up here, reverse the lines in a file. Okay, so reverse the lines in a file. Let's go back here, let's close our programs right here. Okay, so reverse, we have this file here, okay, and what happens, it's this, that, and the other, and we want to actually print those out in reverse order. Okay, so let's take a look at our program here. Alright, here's our reverse program here. Let's move the lines over here to the right so you can see the lines there. And so this is in a file called lines.txt, and here is, let's actually turn on our control structure diagram here. Oop. Oh, and this should actually be, let's see, how, oh, right here, there we go, turn on control structure diagram there, okay. So here is our recursive function here, it's the reverse, okay, and we're going to pass it here, the scanner input here, okay, and so what happens is that we, let's take a look at our base case here, alright, so now, so in this case, the base case, what happens is that you look at this file here and you say, okay, if there's nothing left in the file, once we reach the last item in the file, and this is like you have to think backwards in a way in recursion here, that's what is challenging. So right here, if we say here, if not input dot has next, so we reach the end here, then what happens here is we're going to actually, this is our base case, is we're going to say we're going to print a new line. Okay, so now what happens here is we're going to say end there, and we'll put in a curly brace there, and then system.out.println like that. All right, and now we're going to say here, and now here comes, oh, let's put in our base case right there. So base case, let's put a comment next to that there. Okay, and now let's take a look at here our recursive case. Okay, and of course we should have here, let's put in our else. Okay, so else, put in our right curly brace there, and then on the next line here we're going to have our recursive case, and well, let's fix our indentation here. Well, let's just type it in and we'll fix it. Okay, so then what happens here is we have string, okay, the next is equal to input dot next. All right, and now what happens here is we're going to say, oh, reverse the input here. Okay, and now what happens, so we're getting that item there, like that, the line there, this, and we're saying, okay, now reverse the rest of it. Okay, so we're going to say reverse, so that's all this is, we're going to reverse this here, and then we're going to take this line and actually print it here at the bottom. Okay, so first thing here is we're going to get this item right there. Okay, so string the next right there. Okay, then we're going to use recursion to tell this, put that all in reverse, put it backwards order, okay? And then the this there, it goes all the way down there. So this will print out at the last, okay? And you can see this is here is our base case right there, all right? And then here, oh no, actually base is going to be, I take it back, that would be the just to print the blank line there. Actually, this is not the base case. That is actually going to be reverse the input here. That's this function call. So let's just put a little note there, A, okay? And then here is A. It's like this sub chunk of work there. And now what happens, you're going to see the other chunk of the work here. And we're going to take and print that other portion of the line. And we're going to say system dot out dot print line, and then say the next. All right. So we get that string right there like that. Hit a semicolon on that there. Put in our closing curly brace there. And you can see now that, let's turn on our control structure diagram here, and it looks like here we put in a colon instead of a semicolon, so let's save that there. Let's compile it. It compiles. Okay, turn on the control structure diagram. So once again here you can see the base case here is right there, and now is our recursive case here, okay? And then here is our recursive call, okay? So this is like basically what happens, this is like doing the recursive on the next piece of work. So we just took a piece off of the like the first item, that's the this here, and then what happens, we tell it, oh, let's call it again, and after doing a little bit of work here, let's recursively call it, and now print out that item that we pulled off at the beginning. Okay, so I know that's like a little bit in reverse. It is actually, in a way, pardon the pun. Okay, let's go launch this in the debugger now. So let's go ahead and hit this here. We're gonna actually check it here on the put a breakpoint in. Okay, and now let's do the debugger. Okay, now you can see, now watch our call stack here. Okay, so now what happens, we're going to actually step into the reverse method there. Okay, and now input has next. Okay, you can actually do this here and do interactions here, and see on this one here, because there's really no variable on this here, and you could just say check it out here, because we have our input objects, and it does have a next here, so we're not gonna reach our base case there. So now we're going to go into recursive case here, and now we're going to get the string the next, and there we said it's this. Okay, so that's that first item right there. And now what happens, we're going to do that recursive call in there. Okay, so now once again we're not at our base case. Okay, and now we get the next item, which is going to be that. Okay, so now you see that it's that. Okay, and nothing's printed out here. Okay, so if you look at the IO on this here, we've got no output going here yet. Okay, it's like, in fact, all this stuff here is stuck on the call stack. All right, so here's our call stack. It's at 3 items there. And now let's go ahead, and once again we're going to step into the method here, and you can see the call stack is continuing to grow, and each time it's actually grabbing that next string on there. And now we're going to step into it again. We just reach and. Okay, let's see here, we're going to get step in again, and let's see here, other. Okay, here we go. It looks like now we have reached our base case here. Okay, so you can see right here on the call stack, and you can actually click on each one of these items on the call stack and look at the string that it has on each one of them there. Okay, so you can see that it's like there's a call stack there with the item this, that, and the other. And now what happens is we've reached our base case. Okay, so let's check on the interactions here down here at the bottom and say, oh, do we have a next item? No, we do not. We have actually reached the end of the list here. Now what's going to happen, it's going to unroll that call stack. Okay, so it does a print line there. Okay, so we got that output on the print line. It looks like actually what happens here, we didn't actually need that because it's, and now let's see here, what's it going to do? It's going to unroll. Okay, so now it says, oh, look at this here. What's the next? Oh, other. Oh, look at that. So it's in reverse, so other is going to come out first. Look at that. And now it happens, it's going to actually unroll to the next item. So you can see right there, it returned from this here, and it remembered where the position it was. It finished on that call to the reverse, and now it's printing each line. Okay, so closely follow this here, because each time it's on reverse number 15, and then it's going to jump here to item number 12 there. Okay, so you can see now the text is all coming out in reverse here. Other, so right down here at the bottom, just take a look right here at this. This is the output here. And then notice here that the lines, it's unrolling the stack here. Okay, so right here, and then look at, if I hit next here, now you can see the next item is that, and that is held on the call stack there. And now it's going to execute line number 13 there. I was trying to draw that there on the screen, and now you can see that we are actually at the last item. And now what happens is going to return there from reverse here and go back into main. Okay, and that was where it made actually the initial call into this recursive function, and you can see that it reversed all the lines that we had in this file. And so there we go. It looks like we finished there. The program is terminated. And so that's basically our introduction into recursion. I'll actually leave, we're going to leave off the last item here, star string. I think we've actually looked at a number of items here. Let's just take a look at the terminology here, and just once again here, recursion, that was the whole theme on this here. Up to this point we've used loops, and so in this case here, recursion, we're actually using functions that call themselves. Okay, and so repeated, this is our definition of recursion. And of course, which is important, is our base case. Our base case is like what happens at the end. Okay, but it's the first thing you write about is what happens at the end. Okay, the recursive case is like, oh, okay, reducing the overall problem to a simpler problem. Okay, and then it can be called by this same recursive call. Then of course our call stack, we saw that call stack grow on us there. All right, well, thank you. Hope you enjoyed the lecture, and have a good day.